We're going to review lesson 5.1 through 5.4. This is actually a borrowed format from page 219. I actually changed some of the numbers, so they look exactly the same, but I just have different numbers. So maybe this will help you to work on your homework question and also to review for 5.1 through 5.4. We did not actually work on 5.3. I think it's simple enough for you to pick up because it's setting up equation with proportion. So let's give it a try. If it's too hard for you guys, I'm not going to count it against you. Number 1 question, tell whether the two rectangles are similar. Explain your reasoning. So we're going to take a look at these two rectangles and compare their sides to see if both the length and the width are going to have the same ratio. In order to do that, I'm going to set up the proportion from small to big. And then what I'm going to do is I'm just going to plug in the numbers, top and bottom. For the first set, I have 6 over 15 because I am going to work with the side first here. And then for the second set, I am going to work with this part, the width part. I have two different ways to see if they are proportionate. First is to look at the numbers 6 and 12 and see if 6 can multiply something to make 12 and if 15 can multiply the same number to make 30. In this case, if you multiply 2 from both sides, you can make the number on the right side. So I know that they're going to be proportionate. The second way to solve this is to do the butterfly or the cross multiplying and find out if both sides are going to have the same number. For example, 6 times 30 would equal 15 times 12 and see if they are equal or not. In this case, they are going to equal. So you can explain that they are going to be similar. Number 2 and 3 is asking for you to find the ratios, red to blue, and it's important that you know which one you use first, of the perimeters and of the areas. So you're going to have to find two different sets of ratios. So I'm going to work with the perimeter first. So I put red on the top and blue on the bottom because it's red to blue. If you prefer writing it in format like this, you can also do that. Now, before I go to the next step, I'm going to see if I can simplify the numbers. What I did was I simplified the numbers by dividing it by 2. So my ratio is then 7 over 3. So that's going to be the ratio for the perimeters. For the area, I'm going to use the ratio for the perimeters and just square those numbers. So when I square the numbers, 7 times 7 is 49. 3 times 3 is 9. So this is going to be the ratio for the area. Now we have another one for number 3, which is 5 and 14 for the sides of the triangle. Same thing for the perimeter. I'm going to put the red one first on the top and then the blue one on the bottom. Because 5 over 14 is the simplest way that you can put into a number, you don't have to do anything. That's going to be your answer. And then from here, for the area, you're going to simply square the numbers that you have. When you square the numbers, 5 times 5 is going to be 25, and 14 times 14 is going to give you 196. So that's going to be the ratio for the area for number 3. Now 4 and 5, like I said, has questions from 5.3, section 5.3, which we didn't go over, but I think you guys can handle this because it's something that you guys have done it before. So what I'm going to do is I'm going to set up the equation for the small one and then the big one. I'm just going to call it A and B. So what I'm going to do is I'm going to put this side, which corresponds with the top one, it's just upside down, and put that as a ratio. And that is going to equal to the ratio of the bottom one, which is 10, with the missing x. After you set up the equation, just make sure that you have the same corresponding sides. It's going to look like this. And then you multiply, cross multiply, and find out what is going to be the answer for x. So I'm going to go ahead and do 8 times x equals 18 times 10, which gives you 8x is 180. And then to find out a single x, you're going to divide it by 8. And then find the answer for x, which is going to give you 22.5. Let's try the next one on the right side. Same thing, I'm going to put the corresponding sides. So I'll have 5 and x on the top, and then 8 and 18 on the bottom. So let's go ahead and set up the equation. So I set up the equation. I have the corresponding sides. 8 is a small one, so I put it on the top. Then 18 is the bigger one, so I put it on the bottom. And then for the second set, I am going to put 5 on the top and then x on the bottom. It's okay if you have these two fractions on the opposite side. So if you have 5 over x equals 8 over 18, you're still going to get the same answer. Now you're going to cross multiply and find out the answer for x, like this. When you multiply 18 times 5, it's going to give you total product of 90. And then after that, you're going to simply divide this again by 8, and you'll have an answer of 11.25. Now we're going to look into the bottom half of this worksheet, and we're using scale factor of 1 to 20. So for both 6 and 7, you're going to use 1 to 20. And one thing that you'll have to remember, if you're using a scale factor, that means you're going to have the same unit for both of the model and the actual thing. Thankfully, we have inches and inches, feet and feet, so you won't have to convert anything from one unit to another unit. So first off, I'm going to go ahead and set up my first question by putting the scale factor 1 over 20. Because my scale factor is 1 over 20, I don't have to worry about anything. I just put it like that. And then I'm going to put the model of the height as x because I don't know what it is. And then I'm going to go ahead and put the actual height on the bottom, like this. Your next step is to cross multiply again and then find out the answer for x. So 20 times x is going to equal 1 times 95, which is just 20x equals 95. And you solve for x by dividing both sides with 20. When you divide 95 by 20, you're going to have the answer of 4.75. So your answer for 6 is going to be 4.75 inches. For number 7, you're going to work with feet, and instead of your actual length, you have the length for the model. Again, I used 1 over 20 because that's my scale factor, and then I put the length of the dinosaur model on the top and then the actual one on the bottom. And I'm going to repeat the same steps. Now the difference is because the length is on the bottom this time, I'm actually going to have 1 times x equals 20 times 6.25. So when I multiply this, I am going to actually end up with my final answer. And the final answer is going to be 125. So the length of the actual dinosaur is going to be 125 feet. For number 8, it's pretty simple. You have the ratio given to you for the posters, which is 8 to 21 inches. All you have to do is to find the ratio of the perimeters, which is just putting them into a fraction number. So all you have to do is to either write it in this format with a fraction, or you can just write it again in this format. Number 9 question, as you can see, I actually kept the numbers. So if you're watching this video, this is a freebie for you to work on your number 9 question. We have a dolphin in an aquarium in 12 feet long, and you have a scale model for the dolphin as 3.5 inches. What is the scale factor of the model? So when they're asking the scale factor, I have to make sure that I have the same unit for the model and the actual thing. So I'm going to first write down my equation or factors using both inches and feet and then change it. While I'm doing that, also I changed my 3.5 inches to 3.5 inches because it's easier for me to work with decimals in this case. Now I have inches here and then feet here, but inches are going to need 12 of them into 1 foot, so I'm going to change 12 feet into inches. And how do I do that? I am going to multiply 12 because for 1 foot I have 12 inches. If I have 12 feet, I'll have to multiply by 12 in order to find out my inches. Now, when I multiply 12 by 12, I'm going to end up with 144 inches, and 3.5 inches is going to be on the left side. When you have a scale factor though, you're not going to be able to use any decimals or fractions for the left side. So what I'm going to do is, instead of leaving it as 3.5, I'm going to make it into a number that is whole number, and instead of dividing into any numbers that is smaller than 3.5, I'm simply going to multiply 2 to 3.5 and also 2 to 144 so that my left number can be a whole number. When I multiply 2's, I'm just going to write it on the side here. 3.5 times 2 will give you 7, and then 144 times 2 will give you 288. And that's going to give you the scale factor of the model, 7 to 288, and that's it. So the last question is asking, the tennis courts for singles and doubles matches are different sizes. Are the courts similar? So let's go ahead and take a look at it. We have the length, 61 feet and 61 feet, so they're the same. And then we have the singles with 17 feet and doubles with 23 feet. So are they going to be similar? Why or why not? In this case, they're not going to be similar because their corresponding sides are not proportionate. If they are different, if the width is different, then the length should be also different with proportional sizes. But in this case, their length is the same, but their width is going to be different. So they're not similar. I hope you can use this lesson to help you out solving the questions from page 219 from your textbook. And please refer back before you ask questions, because a lot of times you can find out how to work on your questions. Good luck!